welcome to the IT Monkeys semi-product launch of our Timekeeper application. So just to reintroduce our team, my name is Seung Tran. I was the active team leader on this software development lifecycle. I have Tobias Cash as my acting project manager, and Jesus Ramos and Isaac Allen as our two team members. A little bit of content overview before I get started. We're going to go over our original project initiation and planning, our analysis phase, design phase documentation, implementation phase, a look at our final prototype, and then an overview of our customer satisfaction. Just to take a look at our original problem definition, we were looking at small businesses and contractors with crews that they were having hard times keeping track of. We were trying to avoid hours getting lost, paychecks being incorrect, long wait times for payroll or billing. So our solution to that problem is an easy to use app made for contractors that lets workers clock in and out easily, even when their phone systems are offline. It puts all their information into a clean report without the usual mistakes that you would have without one. And to achieve this, we put together our schedule of work. Our timeline was 14 weeks. Within the first and second week, we gathered our client info, identified our requirements, researched our software, and then in weeks 3 to 4, we created all of our models and pseudocode. In weeks 5 through 8, we updated our logical models with our physical design prototype. We started building and testing. And then in weeks 9 through 12, we started revising our prototype, creating our test plan, documenting our tests and training. And then in weeks 13 to 14, we finished up our testing, we're finalizing our logs, and then preparing our final presentation. So this was our original statement of work, just stating that our system needs to allow users to clock in, clock out, track jobs and tasks, view their recorded time using a calendar-based interface, support two roles, employee and manager with different permissions, completed using classic SDLC methodology, complete with requirements analysis, system design, implementation, testing, and documentation. Our system will be developed using Flutter and Dart and SQLite for our local data storage. And our final deliverable will be a working Android iOS application with complete documentation and a deployment and maintenance plan. And for our feasibility analysis, we looked at Dart, Flutter, Android Studio as our IDE for our technical feasibility and felt that was very feasible. And then for our economic feasibility, it was looking great because all of those tools were free. So we had very low development costs. And then our operational feasibility was also very high since we were helping a lot of small businesses that wouldn't usually have access to a free or low paid app on this level. And then our schedule feasibility was a 14-week timeline, which did seem doable to fill in all of our features, clock in, clock out, offline storage, job tracking, approvals, our report exports. And here's a look at our work breakdown structure. We have our project selection and initiation. We created our statement of work breakdown structure, built our Gantt chart, PERT chart, gathered our client info and project requirements, researched existing apps, and did our buy versus build comparison. And then we assigned our roles and responsibilities and moved into our analysis phase where we created our traditional models like our event table, ER diagram, DFDs, pseudocode, and pseudocode for the DFD process. We then moved on to our UML diagrams, created our use case diagrams, domain class diagrams, system sequence diagrams, activity diagrams, and our state chart diagrams to then be able to move into the design phase where we re-identified our requirements, addressed our security and networking considerations, started on our UI UX wireframes and mockups, started our database design with SQLite, and started building the entire prototype around that and testing all of our main use cases and debugging. And then, designing. And then into our development phase, we started with our clock in, clock out feature, our task management feature, complete with add, edit, and delete options, our calendar view, complete with a connected integration into the tasks, productivity tracking, data storage and sync with SQLite, backend integration, offline storage functionality, and job tracking. And then onto the implementation phase, we continued revising our prototype, creating our test, installation, and maintenance plan to then move on to our testing and Q&A, where we looked at our feature and integration testing, bug fixes, refinements, and then recorded all that into our logs and reports. And for our deployment, we finalized our Android and iOS build, prepared our final documents and user guide, and demoed our presentation. Here's a look at our original Gantt chart that shows all of our tasks kind of on our timeline, our 14-week timeline. I have everything closed up to the analysis phase, so just to take a look at our design phase and get a closer look at our critical tasks in red. We have our assignments of our team members, and then our non-critical tasks. Here we have a non-critical task, UI, UX wireframe. As I went over before, we created our package diagram, and then into the development phase where we started to revise our design plans, the front end development with our dashboard buttons, calendar view, and then our back end development with our UX logic, time tab, logic, database integration, business, our API connections. And then we measured our usability with our security, networking, and then onto our implementation phase down in November. We created the test plan, the training plan, support plan, the testing phase we entered where we revised our prototype again, and then onto our launch. These were our original duration estimates based on the required time restrictions. And this is our PERT chart. So here you can see our block diagram of each parent and subtask. Each block has the duration of the task, the estimated start and finish date, and then the same color coding applies with our critical tasks in red. We have our parent task of the SDLC timekeeper lifecycle, and then our project selection, initiation, analysis, and design phase. I have it opened on the design phase for now. So for simplicity. So to create our prototype, we have our create prototype tasks, and then we can start creating our design class diagrams, database dictionaries, and database schema. And then at the same time, we also had the availability to start on our UI UX wireframe, design interface, package diagram, and API design. And then moving on, here we have our database schema, UX. We go on to the development phase where we start revising our design plans, move into the front end and back end development with our dashboard buttons, calendar view, reporting, and here's our back end development tree where we have UX logic. We're going to spend about 1 day on that, our time tag logic, database integration, business logic, our API connections, and then after that starts into the measure usability phase with our security, networking, a meeting for review, our implementation, installation plan. Here we have that, post-installation plan, training plan, support plan, deliver our documentation, and then as you can see, the dates are on these as well, moving along a timeline. And then we have our testing phase with our testing plan, revisal prototype plan, revised documentation, and then our launch.
For our system requirements, we started by separating the features into must-have, important, and nice-to-have categories. This way, we were able to prioritize the most important features versus the least important. Must-have. First, we have automatic time tracking with GPS, and this ensures that employees can only clock in when they're physically at the job site. Offline capability, since many contractors may not always have reliable internet. Mobile first, easy to use interface so employees of all ages and backgrounds can quickly navigate the app. And finally, task and job management, which lets managers set job sites, assign tasks, and define pay rates. Important features. Calendar and scheduling view. This would help managers monitor shifts and track employee clock-in patterns. Payroll/export integration for smooth processing. And cross-platform consistency so everyone can use the system regardless of their device. Nice to have features include search and filter options for finding specific dates or employees, and notifications and reminders. So, when we analyzed the market, we found that several time tracking tools already exist, such as Clockify, Toggle, and When I Work. These apps offer the basic ability to track time and manage schedules, and they work pretty well for a general use. However, they also come with some limitations, such as subscription costs, limited customization, and many features are designed for larger teams rather than smaller companies or contractors. Next, we evaluated whether it's better to build a custom solution or to buy an existing one. So, building our own system would let us meet all of the must have requirements exactly as needed. We could implement GPS based clocking, offline first design using local data storage, customized task and job management, and a simple mobile first interface. We could also add features like search, filters, and notifications. The main limitations are the time required to develop the system and the need for ongoing support, but the benefits are full customization and long term flexibility. Buying a pre built app would cover most of the must haves, such as the GPS clocking in, clocking out, offline capability, and payroll integrations. However, these apps are often designed for larger teams, meaning that task management and scheduling tools can be a little complex. Nice to have features such as search, filters, and notifications vary depending on the service, and another consideration is the subscription cost. Another limitation is that the client would also need to adapt to the app's workflow. So, this event table outlines the key events in our system and how the system responds to them. For example, when a user presses a clock in button, the system starts the timer and saves the time. Clock out ends the timer and stores the record. Generating a timesheet compiles the user's work hours and exports them as a PDF. We also have scheduling functionality for managers and location-based automatic clock-in triggered by GPS. And this table basically helps us define how the system should behave in response to different user actions or environmental triggers. And this diagram shows the main entities in our system, such as employers and employees, and all of their attributes. It also shows the relationships between them, including how tasks, time entries, and schedules connect back to each other. This layout pretty much serves as a foundation for how we structure and store data in the database. Our context level data flow diagram gives us a high level view at how data flows in and out of the time tracking system. It includes external entities such as employees, employers, and the payroll system. And you can see how each entity interacts with the system through processes like clocking in or clocking out, task management, and report generation. And this just helps us visualize the system boundaries and understand how information moves. The level 0 DFD goes a little deeper. It breaks the system into its major internal processes. And here we can see the interactions between employees, managers, and payroll, and how data is stored both locally and in the cloud. This diagram shows the system's main functions and how they connect. The level 1 DFD it gives more detail or a more detailed breakdown of how an employee tracks their work session. It includes validating entries, starting work sessions, logging breaks, resuming work, and clocking out. The system stores all time records, generates summaries, and exports or reports to payroll. Together, the context level 0 and level 1 diagrams show a complete picture from a top down overview down to a more detailed process flow. And finally, our pseudocode explains how the timekeeper system works internally from a logical standpoint. It walks through the full workday process, displaying options, checking online or offline status, and starting the clock in. During the work loop, users can view the calendar, manage tasks, or log breaks. Um, when the user clocks out, the system stops the timer, reviews productivity, generates a summary, and exports a report. On the right side, we show how task management actions such as editing, deleting, categorizing are handled. We also outline how the system stores data locally or syncs it to the cloud, depending on whether they're offline or online. And the integration module handles GPS verification, notifications, calendar syncing, exporting, and data encryption. And this pseudocode just ensures that the system logic is clear, consistent with the requirements, and that it's easy to translate into actual code.
Next is our use case diagram. This is a visual representation that shows the interactions between the actors in the system. So you can see we have different actors such as the GPS system, the employee, and the manager, and these can all do different things such as clock in or clock out and approve hours for the manager. This is our domain class diagram. This represents the behavior of an object in the system, and you can see the different interactions between all the different objects, such as the manager and employee being able to interact with the user. This is our activity diagram. This is a flowchart that visualizes how a system works step by step. So the user would start the day by clocking in, and then it would check if you have an online connection. After that, you could log breaks or store the time, either locally or on the cloud. This is our system sequence diagram. This shows the interaction between the worker, the timekeeper system, and the GPS service during the clock-in process. The worker initiates the process by opening the clock-in screen. The system requests the device's position from the GPS to verify the worker is where he says he is. And then after checking the position, the worker can submit the clock-in information, including the job ID, position, optional photo, and timestamp. This is our state chart diagram. This shows the different states the program can be in. Of course, it starts in initialization, then it can move to idle, and then you can either clock in via GPS or just the user clocking in, and then it will start the timer, and then you can either end the timer or pause and restart it, and then store the time. This is our design class diagram. It shows our classes used within the timekeeper development process, and you can see all the different classes that we use, such as the company, the clock event, job site, and all the different variables stored. And this is the database schema. This shows how the different elements will be stored in our database. So you can see that the company has an ID of type int or in a name of type string, and the time entry has some different things such as position and time in the form of a float. And finally, this is our package diagram. This shows how the system is organized into different modules or packages. You can see that we have the UI, the different services such as location and payroll export, and then data.
Alright, so now we're gonna show you a little bit of the prototype that we did so far. I just uninstalled the app here to show you guys what this is all about. So I'm gonna basically start the app for the first time. It takes a second to load up. In the meantime, you can see we have a fully functional database on the left here under data with some subfolders. We do have the services tab. Those red lines you see here are not yet completely done files or integrated files, but most of them work. We have the manager mode that works really nice, the clock service, location service. We do have under UI the onboarding part, which is what you see right here, which is only the first time you open the app or you install the app and you've opened the app the first time, you're going to be sent to a certain screen. So the first one, wizard and the profile onboarding page. And yeah, but let's go right into it. And so the first time you open the app, you're going to be asked to create a company or to join an existing company. Now, since we don't really have other existing companies yet, we're just going to create a company, which is called Pima. Okay. The manager pin, let's say, is 0000. Confirm pin is 0000. Okay. We click on create. There we go. Company is created. You get even a join code. So now, where do I find all this information now? Now you go under settings and you see you are in the company Pima. You see the join code. So if somebody wants to join your company, yeah, you can click and enter the company code. And so then they're going to be basically an employee under this company. Now, right now, we are also just a regular employee. So we want to enable the manager mode, which, what we said, 0000, right? Now, somebody comes in and says, oh, I know the code, it's 4444. No, it's a wrong pin, right? So that is very secure, very proof tested. And so it's 0000, right? Now that worked. Now the manager mode is enabled. So now we can create tasks. We can do everything. In the calendar. Now we want to create a profile. Now we can type in the name. My name is Toby. My email is xyz@pima.com. Okay. My phone is 123 458 7878. Okay. And then my role is manager. Device label, that's a work phone. And then you can even go so far and add your own profile picture, which on this emulator right now, we don't have that. But you can if you want to. Okay, so we go on save, and now you see I am Toby. You can edit that stuff and everything. And so now, you know, as a manager, you want to create tasks. So you can go ahead and click on the plus button, create a task title. What do we call this? Let's say this woodwork. Okay. No, I'm not that creative, but woodwork category, wood client. Let's say we do some woodwork for Pima Community College. Let's say Pima. We do actually do that weekly. Okay. We can assign an employee. Yeah. We gotta still figure that out a little bit better, but it works so far. Then we can go ahead and pick a date. When is the first day of work? Let's say it's tomorrow on Friday. Okay. And then we pick a start time. When you start working, you know, usually they start at 7 in the morning. Let's do that, 7 a.m. Perfect. end time, say, is start early, you quit early, right? Let's say 2 p.m. Yeah? And so we save that job and click on the calendar. Now you see the little blue button here. You can see everything: category wood, client Pima, starting time, end time. And then let's say we have another one. We have painting, category paint. Is that I'm very uncreative. And then client is again Pima. Returns bi-weekly. Okay, we assign again the same employee because we only have one so far. Starting date is the 14th, not the 15th. Nobody works on Sundays, right? So on Monday, and then start time for that is going to be 8 a.m. Usually you can do this with a finger. It's kind of nice. And then finishing time is going to be 4. I'm going to save that one in the calendar. You can see now it is right here. And of course you can, click through everything here. But yeah, so the things are going to be saved. You're going to get all the details down here. And yeah, then we have the clock in and clock out screen where you can say, okay, you're here at 8, you're going to clock in at 8:05. It's going to be recorded, and so they know. I mean, there's some grace period, but they know you didn't start at 8, you started at 8:05. And it's also going to keep track of everything you did. You did your break at this and this time, and you can also go ahead and create subtasks here. You can do so many things.
Hey, and this slide just outlines our technical implementation and development process for this final project. Again, we implemented our core system features and UI using Flutter and Dart. Flutter and Dart allowed us to use one code base for multiple platforms. It also allowed us to integrate SQLite for our persistent local data storage. With that, it stores all the user's data on the device. We also used GitHub for our version control and team collaboration. GitHub allowed us to collaborate with each other seamlessly and push up different versions and work off multiple different versions of the same app. So that was really good. And just to summarize this project initiation or launch, we did have some client requests that are not yet met. Our GPS clocking in and clocking out system is going to need a little bit more time to debug. We also need a little bit more time with debugging our exporting timesheet. All the main things are in place. And then with those two things figured out, it would be a completely finished app. And then for the client requests that we did achieve, we did finish our onboarding and first run wizard. We implemented a successful new user guide for our setup. It has 0 errors, perfect time, great user experience, and then we achieved our profile creation feature. It allowed us to include role-based settings and preferences, and it ensures for a personalized access that works seamlessly with the company creation, and adding different profiles and creating companies and scheduling users and grouping employees and things like that. And then we also achieved our employee calendar task view schedule, which all work seamlessly with the profile and the company codes and the tasks and yeah. But thank you for your time to watch our project launch. These are the resources we used to learn Dart, Flutter, implement SQLite, and build what we have. But yes, thank you so much. It's been a great semester.